Hey, I want to introduce you to a new library. It's a code generator for the format DAG JSON. If you don't know DAG JSON, DAG JSON is just it's basically a super type of JSON. It's made for IPLD. It's compatible with JSON in all aspects. So you can literally put any DAG JSON input into a JSON parser and it will be fine. However, DAG JSON has a particular format for things like bytes and links, and you can see the format looks a little bit like this, right? So you've got for bytes you have a slash and then an object with a bytes key and then the string, which is just base 64, not padded. Binary data. And so for links, for SIDs or CIDs, similar sort of arrangement. Basically, any object with a slash as the first and only key in it is a kind of special thing in DAG JSON world. And so for links, we have a slash, and then if it's just a string, it will be a V0 SID or a V1 SID, and if it's V1, it will be base 32 encoded. If it's V0, it will be normal base 58 BTC encoded SID. So DAG JSON, this library is very similar to this other library called CBOR Gen, and this is a code generator for CBOR. So if you want to basically have some structs in Go and encode and decode to CBOR, then you might use this library to generate the code that will allow you to do that really easily. So DAG JSON is the same. It's exactly the same library. It's actually a fork of it, but instead of outputting CBOR, it outputs DAG JSON. So I'm going to take you through a demo of how it's used. I'm going to create a kind of NFT collection, so some structs for that, and show you how to generate the code for marshalling and unmarshalling DAG JSON data, and show you some of the features that the library has, which CBOR Gen also has, to be fair. But yeah, just show you how, just in case you're not familiar. So let's begin. So I've got this empty project here. I'm going to define my types for my NFT collection. So I'm going to create a folder. I'm just going to call it types. I'm going to create a file in there. I'm going to call it types.go. Anyway, so we're in the types package, and we're going to define an NFT collection. It's a struct. And it has a few fields. It's going to have a name, which is just a string, and it's going to have a collection, is a collection of items, and typically for NFTs is like NFT metadata. So not the actual asset itself. Each NFT has this kind of idea of metadata. So this is going to be a slice of meta. We're going to define meta down here as a struct. There we go. Meta is going to have like ID. Each NFT is going to have an ID. That's going to be an uint64. It's going to have an ID. A name is going to be a string. So each NFT has a specific name, and a description. Description is going to be a string, obviously, as well. And then what it will have is an image, which we're actually going to use a SID for, because this is going to be we're actually going to use a link, an IPLD link for the image, so a link to the asset, the hash of the asset. So we're all content addressed and good. Every NFT sort of typically you'd have like attributes for an NFT, but we don't know what these are going to be. So these are just going to be a slice of bytes. So this is just generic attributes for an NFT. So we could reuse this these particular structs for any NFT collection, basically, because it's generic in that sense. And also using SID and byte lets me show you how the encoding works for DAG JSON. Cool. Okay, so typically what you do now is you create your kind of type generator. This is just a file, or a Go file, I'll call it main.go, which will generate it will generate our code for our types that we ask it to. So if we just create our main function, I'll show you how that works. We need to import JSON Gen, and that's GitHub. Hi. Typos everywhere. So it's called DAG JSON Gen, so similar to Seawall Gen. And so what you can do with this is you say you want to write the files. We're going to use this thing called map encoding. File name, we're going to put it in types, and we're going to call it DAG JSON Gen. Go, because this is a code generator. It actually generates Go code. The package name is going to be types because that's where we're putting it, and then we literally define our types. So what we want to do is just put some error handling around this, just in case things go wrong. Panic. So now we just define the types that we want to see in that file, and we're going to use types.collection that we created, our NFT collection, and types.meta, which is our actual NFT itself, or its metadata for the NFT. So we're saying generate map encoders for these types and put them in this file. The package name is types. So what we can do now is we can run that. So we go run /types gen main. And that should just create this file called DAG JSON Gen.go. And if we look inside, we can see that for each type, we have a Marshall DAG JSON method. And you can see what it's doing here. It's like writing an object open, so that's the curly brace. And then it's writing the ID colon, and you can see that it also creates a this is Marshall, unmarshal, yeah. So it creates unmarshal functions for each of the types that we've defined as well. That's cool. You don't really have to do anything with that. You don't even edit it or whatever. There's no need. So you just basically leave that alone. But that's just added those methods to our types now, so we can now actually go and use them. So let's do that. I'm going to head over to our main function here. We're going to create a collection, and it's going to be a types.collection. There we go. It's going to be, we're going to call it like, let's make an NFT collection of like dinosaurs, zors, dinosaurs. Okay, why not? So yeah, okay. So the collection has a name there, and obviously there are items in the collection, and we don't have any of those yet. So let's create those. Let's create those items. So that's our collection. We're going to create our first item, which is going to be Dino 0. Yeah, that will do. And this is a types.meta, and this has a name. This is going to be like the T-Rex. Description, short arms. It's going to have short arms. ID. Let's make ID 1 first. First one. What else do we have on here? Image. So for this, we're going to use a SID. So we're going to pass a SID in here. SID.parse. And let's just grab a SID from anywhere. Here we go, here's a SID. Pass a SID, and then the image is going to be image, and then we've got our attributes, which is the generic chunk of bytes, dependent on the actual type of collection we're creating. We're just going to put 1, 2, 3 in there for now. And then we need to collection.id, item, so we need to append the dino 0 to our collection. Okay, cool. So now we've got our collection. What's wrong with this? Okay, or whatever. Okay, so let's marshal. Let's turn this into DAG JSON. So what we call is marshal. We need a writer, so we need something to write it into. We've got a buff bytes stop buffer. Bytes buffer. Marshal it into there. The address of there, and that should do it. So what we'll do is we'll just print out what happened. Buff dot string. There we go. I think that looks pretty good. So let's. Here we go. So go run main. Hey, and there we go. And we can pipe that into JQ to have a bit nicer output. So that's kind of cool, huh? So we can see our DAG JSON encoding here. We've got the slash with the SID in it. We've got our attributes, which is a slice of bytes, and we said that they are specially encoded, base 64 stuff there. The only thing about this is that our field names are all capitals, and JSON typically you don't normally see that. So let's go and fix that. Let's go and fix that right now. So what we do here is just like with JSON, DAG JSON Gen has struct tags, and we can say things. I want to call this name in the output. I want to call this items. So you can do the same thing with JSON, but this is a similar thing where you can specify options for your encoding. It's going to be ID. DAG JSON used to be Gen. DAG JSON Gen. Sorry. There we go. Whoa. Oh, whoa. Sorry. Name. That's going to be. I'm going to call this desk for short. Img and atters. There we go. Cool. So if you make changes like this, then you need to go and regenerate your DAG JSON Gen file, because this is no longer correct. So you can remove type/DAG. Yeah, so you can remove this and then run our generator again. And if we run our main program again, we should now see that we've got our nicely renamed names. Okay, that's cool. So we've got that. That's all working. And just to show you that this actually works, I've marshaled it. So I've got this string of JSON bytes there. I can unmarshal things as well, obviously. So if I create like a new collection object, it's a types.collection, and I call col2.unmarshal. Oh, I don't need that, do I? I could just pass buff straight in there. Lovely job. Collection 2. So I've got collection 2, and then I can just print out. If I print out the collection name, name, just to prove that this will work. I'm not going to pipe it to JQ because it's not going to be a valid JQ anymore. But it's called dinosaurs, like items. I've got all my items in there. They've all unmarshaled. T-Rex. Yeah, exactly. Cool. So that's all working nicely. Cool, and we fixed the names, so the field names, so that's good. And then so this one cool thing that Seaboard Gen has is that you can choose to encode your structs as tuples instead of maps. So I can specify this. So what I might do actually is I'll do that. But I'll also have a separate file. We're gonna call this. These are our tuple gens. I'm not gonna. So I'm only gonna generate tuples for meta. Collection is going to be a map as usual. And what this means is that instead of having an object with keys and values, every item will just be an array with the values in it, and that's kind of cool because it's really compact encoding, but it does mean that the order of the items in the array is like like they have to be in a specific order each time you encode and decode them, because it's the order is the thing that matters. If you change the order, then it's not going to be able to decode it properly. So I've done this. I'm going to remove type /DAG. Just going to remove the things that I've generated so far. I'm going to run the code generator, and I should get 2. I need to save it first. Should get 2 files now. So one for my map types and one for my tuple types. Excuse me. And then we can run that same program again. I don't need to change anything. I should just be able to run main.go and pipe it to JQ. And you can see that instead of our items previously were like each item is an object with ID, image, description, etc. It's now an array with just those values. So that's pretty cool. That's just something that DAG JSON Gen supports. And that's used in Filecoin quite a lot for all of its data that gets serialized, because it's just really compact, really compact format. So that's really cool. I'm not gonna do that though. I'm gonna just change that back because for this purpose, for NFTs, we don't usually do that. So let's change it back. I need to remove our types, need to regenerate them, and then we're back to how we were. Now, one other thing it supports that also you can do in JSON is if you've got if you don't want to set attributes, then you can just like you'll end up with like an empty bytes. But you can also say go in here, edit the tag, and say okay, emit empty. So when it's empty, don't actually encode it into JSON because it's empty. Don't worry about that. And so if I do that same thing again, that dance of remove, regen, run, then this time around attributes won't be there unless it's defined with some data in it. So another thing that you can do. There's also other options like for tuple encoding, you can specify that the items at the end when you're decoding are optional, which is fine, and stuff like that. You can also specify that the max length of the field. So if you've got a slice of bytes, you could say, I think you can say max len equals 5,000, and you only allow data that is less than 5,000 bytes to be decoded, which is kind of cool. You don't end up blowing out your memory just trying to read some data. Cool. So emit empty. So that's super cool. Now, the last thing I wanted to show you was this awesomely powerful type that CBOR Gen has, which is the deferred type. It allows you to have generic structs like this, like for our NFTs, where you don't like. The problem with this is like our attributes are kind of byte encoded, so it's like so typically when they were being when we did have some data, I can't read that because it's just bytes, and this part of the awesomeness of like JSON is that it's kind of human legible, and if we're just going to encode things as bytes in base64, then that makes that less good. And also, like, this NFT collection is about dinosaurs. I might want to have use these same structs for an NFT collection about cats or whatever. And my attributes are going to be specific to the NFT collection. So I'd like to be able to decode that data, but be able to and have it encoded in a human readable type in JSON, but be able to kind of allow the same structs to be used with it for different NFT collections. And this tool that you can use, it's probably better if I just use this to show you, demo it, because I'm not doing a great job of explaining it. So let's try and do that. You can use this thing called deferred, and it basically defers passing or encoding of the data until a later time when you do know the intended structure of the data. There we go. So instead of byte, I'm not going to use that anymore. I'm going to use this JSG.deferred. There we go. And so for our Dino collection, we're going to have Dino specific attributes. Dino atta. It's a struct, and they're gonna have like speed is gonna be uint again, I guess. Size uint again, and color. Why not? That can be a string. Now this is really simple. This could just be a regular map, but it's nice to have the kind of type information in there. And this could have other structs here in any one of these fields, and it'll be nice to be able to decode those. So what I'll do now is add this thing, these Dino attas, to our type gen. Let's remove what we've got so far. Regenerate. That's pretty cool. Now let's try and use this. So our Dino, we're going to create some Dino 0 attas attributes. And that's going to be a types.Dino atta. And it's going to be, for our T-Rex, our size is going to be pretty big, like 7. Speed is pretty small, I'd say like 3. And then color, I don't know what color, like green? Green, a green dinosaur, lovely. So, what do we do with this? What we can do here is we can call Marshall. We need a buffer. Marshal it into our attribute buffer, and then what we can do is we can say Dino 0 dot attributes dot raw. Yeah. No, sorry. Equals. It's going to be a deferred. It's going to be a deferred object with a raw property that is the encoded data. Bytes. There we go. JSG. Oh, we need that. Let's import this. There we go, and we will add that Dino to our items as we did before. Cool. So now our Dino, we're using a generic NFT metadata structure, but our attributes are Dino-specific attributes. And so in theory, I should just be able to run this again. Nice. And so now our output looks like this, where our attas are no longer just some opaque bytes. It's actually some JSON data that we've put in there. And then on the decode side, we can decode like any collection. So we've got any NFT collection, anything, we don't care, but we'll find that attributes, like if we log out the actual raw data here, we should see some JSON data. It's just going to be a string, So it's actually bytes, right? But we will output a string so that we can see what this is. And all that happens here is when you use deferred and you try and unmarshal DAG JSON, it will parse the JSON structure just so that it can read the rest of the data, but basically leave that chunk of the object as a bunch of bytes that you can decode at a later date, and that's exactly what we'll do now. We'll just log out what's happened to it. If we just unmarshal that collection, this should be some JSON data for the Dino attributes. So let's just log that out. So because we're printing out that whole thing. Let's just print out. So these are just the attributes, and what we can do with that is we can create our Dino atter, Dino 0 atters 2, and that's a types dot Dino atter. There we go, and we can say, all right, I want to unmarshal that data, and use a new reader for that, and we just grab hold of that data. There. Unmarshal it, and then we can do, let's just print it out. So we're going to print out like size, and what do we have? Color and speed. There we go. So we print out, that's our data, and this is our unmarshaled into a struct, a Dino specific struct for Dino attributes, and then printing out the data. So that's about all that I wanted to show you, and that is DAG JSON Gen, which is very similar to Seaboard Gen, and hopefully useful to someone. All right, thanks for listening. Bye.